Okay, so we just finished looking at logarithmic scale and we could see these two graphs, right? So there's the US right there and there's the US right there. And then we were supposed to label each graph's axis as log or linear. So you got to look at them and you got to figure out, okay, am I going up by the same amount every time or am I increasing exponentially? So let's look here. The horizontal axis here, 2, 3, 4, 5, 6. Okay, that's totally linear. I'm going to insert a little text box that says linear. Okay, going up there. All right, hold on, I'm going to make that smaller. There we go. All right, so this one's linear right here. What about the x-axis over here on this one? So in graph number 2, 2, 3, 4, 5, 6, and so on, that's also linear. So I'm going to put a little lin down there. Okay. All right, what about the vertical axis? Okay, so this vertical axis over here, look, 2, 4, and it goes to 6. That seems good so far. But then 10, 20, 40, 60, 100, right? 100, 200, 400. It's multiplying by twos, and then it's kind of changing how it wants to go. So they're changing the numbers every once in a while, but it's definitely still multiplying. So this is log. Over here, 25, 50, 75, 100, and so on, that's completely linear. Okay. All right, so we've labeled the graph's axis as logarithmic or linear. Which is the better graph? Well, hands down, it's graph number 1. Graph number 1 is better. The data isn't so packed at the bottom. You can actually differentiate between countries, etc. Right? So you can see all the different points around here. So the thing about infant mortality is it gets crammed down at the bottom because you can get very high values of 100 and so, right, 150 and so on. But most countries are down here in the low numbers. So if you do exponential, you can see, hey, you know, countries are different from each other. Like here we are at about 7 or 8 and so on. So you can really differentiate between the low countries where most countries are, but the few countries that are up in the hundreds, you can see the differences between them too. So it does a really good job. Logarithmic scale does a really good job at decramming, unpacking, spreading, yeah, I'll put it this way, spreading the points out so we can really look at the differences. All right. What about this graph? I wanted to talk, so this was looking at exponential stuff, but I wanted to remind us about this guy right here that has no relation. Because I too often get to the point where I think, oh, no relation, that means that nothing's going on. And that's not the case. There are things that are going on, and you can often look at graphs that have no relation and pick up some really interesting ideas. But you have to know what you're looking at. So here's a graph that has no relation, quote unquote. But it has some really important things to say about the world. This is the adults that have HIV. Matter of fact, let's do this. The explanatory variable is income per person, GDP per capita, just like before. We've seen that before. Right? It's the wealth of your nation. And the response variable, look, is the adults with HIV, and then it says percent age 15 to 49. So it's the percent of the nation that nation's adults, living with HIV. Oh my gosh, HIV, I could spell. There we go. All right, now what about our axes? Are they log or are they linear? Well, look, the vertical 2, 4, 6, 8, 10, 12, 14, that's totally linear. Okay. What about this scale? 1,000, 2,000, 4,000. You're multiplying by 2 there. So that is log.